Hello friends, welcome to Tech Study Cell. In this video, we will discuss how you can control multiple ESP32 ESP8266 from a same web dashboard without any third-party IoT app. Now if you have multiple rooms, you can use either ESP32 or ESP8266 for each room. To control the relay, I have used Realtime database and I have deployed the complete web dashboard on Firebase hosting for free. After login, you have to select the room from this drop down. Then you can easily control the relays from this dashboard. You can also control the relays manually with switches or push button and monitor the real-time feedback if the ESP32 or ESP8266 connected with the Wi-Fi. Now let me change the room to kitchen to control this NodeMCU, and from the same dashboard I can also control the relays connected with this NodeMCU. You can also add, delete or edit room names according to your requirement. And you can also set the timer for the fourth relay. Now let me change the room to bedroom and set the time 1 minute. You can select either minute or hour. Now let me start the timer. Here you can see the fourth relay automatically turns on and we can monitor the real-time countdown on the dashboard. Now as you are using free plan, Firebase will fetch the countdown details from the ESP32 after every 10 seconds and it will sync with the web dashboard. Now let me turn off the complete supply. And here you can see now it is showing disconnected. Now let me turn on the supply again. As the EEPROM active, the fourth relay automatically turns on. The ESP32 will automatically reconnect with the Wi-Fi within 10 seconds. Also the countdown will start from the previous save time. Here the EEPROM also saved the countdown details. This makes this project very practical and useful, and after the countdown ends, the relay automatically turn off. In the code, you can also enable or disable the EEPROM, select the relay type, also set the manual control with latch switch or push button. I have also discussed how to reduce number of server requests to make this type of home automation project under free plan. So if you have multiple rooms, after watching this complete video, you can easily control all the appliances from same dashboard with Firebase. So without any further delay, let's get started. This video is sponsored by Altium, a world-class PCB design software trusted by many of the biggest electronic companies. The user interface is so simple, you can easily design any complex PCB in Altium. It brings together PCB design, MCAD, data management and teamwork. It also provides centralized cloud storage, automatic backup and many more powerful features. And if you are a student, you can also enroll Altium Student Lab for free to get access Altium software and online PCB design courses. After completing the course, you will also receive a certificate of completion from Altium. There are many other key benefits, so I highly recommend checking out the Altium Student Lab. You will find a link in the description. Just enroll using your university email ID. It's a great opportunity for students and a great initiative from Altium to help you grow your skill in electronics design. These are the required components. You can either use ESP8266 or ESP32 4-channel relay module. For manual control, you can either use latch switch or push button. Now we have to connect all these components as per this circuit diagram. In the circuit, the switches connected across the GPIO pins and ground. If you need an indicator LED for the timer, then connect it with the D15 GPIO. Otherwise, you can also skip this LED. Now for the push button, again you have to connect this push button across the GPIO pins and ground. For the NodeMCU, I will recommend you to use push button for manual control. Otherwise, you can also connect latch switch, but if you use latch switch, then the switch 2, which is connected with the D3, must be turned off during the booting process of the NodeMCU. Now we will quickly configure the Firebase console for this project. So just enter Firebase console in the Google. I will also share the link in the description. First, you have to create one new project. So I will click here. Give a project name ESP Smart Home. You can give any other name. Click on continue. I will disable the Gemini option. Again continue. Also disable the Google Analytics. Click on create project. It may take some time. Now click on continue. So this is our project. First we will create the authentication. So I will go to security, then click on authentication, then click on get started, select email password. I will enable it, then save it. Now go to user tab, then click on add user, enter any email ID which you want to use for authentication, then enter the password. You need this email ID and password while programming ESP32, so save it in a secure place. Now click on add user. Now it will also generate a UID which we will use in the database rule. So now I will go to database and storage, then I will click on real-time database, then click on create database, select your nearest location, then click on next, select start in test mode, then enable. So you got the link for the real-time database. Now we will just upload a JSON file to create complete structure. So I will click on this 3 icon, select import JSON. Now let me go to the JSON file. Let me first open this JSON file with Notepad++. You can also download it from the video description. In the structure here you can see I have added 4 rooms: bedroom, living room, kitchen, office. So if you want you can delete any of the rooms, then upload the structure according to your requirement. Now let me close this file. I will just drag and drop this file to import, then click on import. So here you can see our database structure created: bedroom, kitchen, living room, office. After that we will define the database rules. Now for the database rules, let me open these files. If you want any authentication user can access the real-time database, then you can use this. Otherwise, if you want any specific user will use the database, then you have to mention the UID. So I will just go to authentication tab. So here we have created this user. I will copy this user UID, then I will paste it here. So only this user can access the database right now. Now I will copy this rule, go to real-time database, then go to rules tab, then paste it here, then click on publish. After changing the rules, our database is ready. Now we will quickly go to setting, then click on general. From here we will create a web app to generate the authentication token. So I will click on this icon, give a name ESP Smart Home V1. You can give any other name. Click on register app. So you got the API key. Now we will just click on continue to console, and here you can see this is the API key. So our Firebase console is ready. Now let me move to the coding part of this project. This is the source code for this project, and this is the web dashboard HTML. You can download all these files from our website iotcircuithub.com. Just visit the article. You can find a link in the description. Then you can download the source code HTML files from these buttons. Then open the sketch with Arduino IDE. For this project, if you are using ESP8266, then install the ESP8266. Otherwise, for ESP32, install the ESP32. I have also mentioned the version that I am using, and you have to install this library. You can use the same code for ESP8266 and ESP32. Now first we have to mention the Wi-Fi name and the Wi-Fi password. Then here we have to enter the API key. So let me go to the Firebase account. So under the setting, go to general, and from here scroll down, you will get the API key. Let me copy the API key. Here I will paste it. After that I have to enter the database URL. So again I will go to Firebase, then go to real-time database. I will click here to copy the link, then paste it here. After that I have to enter the authentication email and password. So let me go to the Firebase, go to authentication, then this is the email ID. So let me copy it, paste it here. Then the password I have used for this email ID. Now if you want to connect multiple microcontroller with the same database, then this string is very important. Here I have defined a room. So I will use this microcontroller for the bedroom. So I mentioned the bedroom here. If you want to use it for kitchen, then just copy the kitchen, then enter room, kitchen. So here you have to mention the room name. After that, if you want to use EEPROM, make it 1, otherwise you have to make it 0. For the active low relay, you have to make it 1. For the active high, make it 0. Then if you want to use latch switch, make it 1. For the push button, you have to make it 0. So you can use the same code for different type of circuit. Now this portion is very important. Here I have mentioned different time delay as we are going to use free plan of the Firebase. So after this delay, ESP32 will check the Firebase for any update. If the timer is activated, the Firebase will fetch the countdown details after every 10 seconds. Then this time save interval is for the EEPROM. After every 10 seconds, EEPROM will save the countdown so that after load shedding, you can fetch the last countdown details from the EEPROM. Then this is the time interval for the Wi-Fi reconnect. Then this is the debounce delay for the switches, and this is the relay boot delay. This delay will ensure the relay should not turn on and off during the booting process. So you can modify this delay according to your requirement. Then this is the GPIO details for the ESP32, and I have commented the GPIO details for the ESP8266. So if you go through this code, you can easily understand. Now let me upload this code. So let me select the code ESP32 ESP32 dev module, then select the proper COM port, then hit the upload button. So if you face any query, you can always let me know in the comment section. I will also explain the complete code line by line in the same article you can find in the description. Now I will upload the same code to NodeMCU after doing some modification. So let me disconnect the ESP32 and connect the NodeMCU with my laptop. Now in this code, I will just change the name. Let me use the NodeMCU for the kitchen. So I will copy the name kitchen and paste it here. Now if you want to give any other name, you can change the name here, and you can also change it in the database structure. Here I will use the EEPROM, I will use active low relay, and here I will use push button for the NodeMCU. Then I will not change these details. I will comment all these GPIO details for the ESP32. Then I will uncomment the GPIO details for the NodeMCU or ESP8266. Now if you want to use separate circuit, you can also update the GPIO according to your circuit. Now after doing these small changes, let me upload this code to NodeMCU. I have to select the tools, board, ESP8266, and from here I will select the NodeMCU 1.0. Then I will select the proper COM port, hit the upload button. So you can use the same code for different microcontroller, and you can also modify some flag according to your circuit. After programming the NodeMCU, let me close it. Now we will configure the web dashboard. So let me open the index.html with Notepad++. Now in this HTML page, if you scroll down, you will find on the room details. If you want to delete any room, you can delete it from here. And if you want to change any name, you can change the name and the value for that name, and you have to mention this same name in the database structure and in the Arduino sketch. Now here you also have to mention the Firebase credential. So in the Firebase config, you have to change the credential. So if I go to Firebase console, then setting, general, then if I scroll down, I have to copy all these details. Then here I will paste it. After doing these changes, let me save it. So our dashboard is ready. Let me close it. Now we will deploy the dashboard on Firebase hosting. For that, first keep this file in a particular folder, then open command prompt. Now you can also refer this article to step-by-step guide. So first you have to make sure you have installed the Node.js in your PC. So let me paste this command. So here I can see the version. So the Node.js is installed. Otherwise you have to install it from this link. Now I will copy this and paste it in the command prompt. It may take some time. Then I will copy this command, Firebase login, paste it in the command prompt. Here I have already logged in. Otherwise it will open a pop-up and ask you to log in your Firebase console. After that, as I said, I have kept this index.html in this folder. So I will copy the complete path. Then here I will type cd, then paste the path to go to that particular path. Then again I will go to the article. So here you can see I have kept the index.html in a particular path and change the path in the command prompt. Now I will copy this Firebase init hosting, paste it in the command prompt. The process is very simple. Now we have to answer some question. Let me type why. Here I will use existing project, so I will hit the enter. Then I have to select the project name, ESP Smart Home V1. This project we have just created. So let me hit the enter. Now if I go to the article again, here you can see it will ask this question. So for the public directory question, I will enter dot. Dot means the current folder, as we have already changed the path. So I will enter dot, hit enter, then type n, hit enter, then again select n, hit enter. Then I don't want to overwrite, again select n, hit enter. Again I will select n, hit enter. So it says Firebase initialization complete, and if I go to that particular path, you will find all these files created. Now we can deploy it. So for that, here you can see these files already created in that particular folder. So I will copy this command Firebase deploy, go to command prompt, paste it, hit enter. So it will deploy all the files to the Firebase hosting. So here you can see we get the URL. So I will just copy this URL, and if I go to browser, paste the URL, we should see the dashboard. So here you can see this is our dashboard. Let me enter the authentication email ID and a password, hit login. So this is our dashboard. Here you can see our circuits are ready, and this blue LED indicates both the microcontroller now connected with the Wi-Fi. So I will just open the browser, paste the URL of our dashboard. So this is our dashboard. You can also save this page in your home screen. Just tap add to home screen, then add. Now let me log in with the authentication email ID and password. So this is our dashboard. Currently bedroom is selected, so I can control this ESP32 from this dashboard. Now let me control the third relay with this manual switch. And here you can also monitor the real-time feedback if the ESP32 connected with the Wi-Fi. Now we will change the room to kitchen to control the NodeMCU. So let me select kitchen. Now I will control the first two relay from this dashboard. Now let me use the push button to turn on the third relay, and we can also monitor the real-time feedback. Now we will set the timer for the fourth relay. So let me select 1 minute. You can select either minute or hour. So I'm selecting 1 minute. Now if I start here, you can see the fourth relay turns on, and we can also see the countdown here. So this is a very useful project. Let me turn off other three relay from the dashboard. So currently only the fourth relay is on, which will automatically turn off after the time delay. So this is a very useful project. After watching this video, now you can control multiple microcontrollers from a same dashboard to control all your appliances together. Now the only thing, as you are using free plan, if multiple microcontrollers connected with the same database, sometimes you may face some delay while controlling the relay manually. So if you find this project helpful, then please hit the like button and share it with your friends. Don't forget to subscribe for more such videos. Thank you for watching. Have a great day.